Hello there, this is Hans Forschner with Navcon Engineering Network. A couple weeks ago, SoundPLAN released SoundPLANnoise version 9.1. In today's video, I want to go over the version 9.1 highlights. For a comprehensive list of changes and developments, please review the update letter published by SoundPLAN. There is a download hyperlink in the video description below. Let's get started. SoundPLANnoise version 9.1 is released with a 64-bit software version. The SoundPLANnoise 32-bit version has been kept up through version 9.0, partly due to the requirement for certain software interfaces, such as TNM 2.5, that required a 32-bit version. That has changed, and from now on, SoundPLANnoise will only be available as a 64-bit software version. With a 64-bit version, there is no 3 GB data limit to allocate memory during the computation runs, and there is a slight improvement in the processing speed, maybe around 15 to 20%, depending on the prediction model. In SoundPLANnoise version 9.1, there are several new developments and updated standards. Node 2000 Road and Rail has some changes in terms of parameters and propagation model changes and a Lmax calculation. There's a new Norwegian Node 2000 implementation, Son Road 18, a Swiss road model includes new input data to allow traffic inputs by time periods. Schall 3, a German rail noise model, has new data interfaces to a traffic information database based on German vehicle categories. One of the bigger changes in this release is ISO 9613-2 from 2024. That is the attenuation of sound during outdoor propagation, and the part 2 is the engineering method for prediction of sound pressure levels outdoors. So this is a very generic environmental noise standard. Overall, this new ISO 9613 standards integrates recommendation from ISO 17534, which released the part 3 in 2015 with recommendation of the implementation of 9613-2 for software application. So the main changes that we have is reducing and improving uncertainties for the subdivision of extended sources, line area sources. It also improves and details specific determination of ground factors, integration of the ground factor in terms of short distances and low heights. It also harmonizes the general method for the ground calculation and the simplified method. There's several changes in terms of the average height, that's for the simplified method, and new algorithms to calculate the screening. That's all per ISO 17534-3. That also includes new barrier attenuation and the effect of the metrology, this K-met factor. And those changes supposedly, or will hopefully eliminate some of the shortcomings with low noise barriers or for larger distances between source and receivers. There's also more specification in terms of the combination of vertical and lateral diffraction around barriers. Improved specification of the width and height of a reflective surface, at what size will a reflective surface be considered. Also additional consideration for multiple reflections with higher orders, and also the reflection of cylindrical surfaces, vertical cylindrical surfaces like a chimney or a stack. And there's also additional parameters or new features in terms of foliage calculation, and there's also more detailed methodologies to consider other parameters. There's also a directivity correction for chimneys that also is based on temperature and temperature of the flue gas, and I believe the diameter of the chimney. And finally, there's also some notes or changes in terms of the calculation of wind turbines. So let's get started here. I'm opening up the Geo-Database, and I would like to go over some of the changes in version 9.1. Some of them, of course, with the standards. So I'll get started and open up one of the situations here. It's called single cycle cogen peaker plant, and this peaker plant has a stack. So let me zoom in there. So here we see the stack. A stack object is up here under environments. So here we have the environments, this little green vertical cylinder. So when we select that, we can click basically on the center of the stack or the center of the cylinder, and it opens up a property window where we can give the name, where it's located in terms of geofile, the type of object, and then of course height, the radius, and then if you type in the radius, it automatically calculates the diameter and the reflection loss. We can also float that cylinder. So here is also cylinder floats above ground. All right. So here we already have a cylinder and we have a point source on top of it. So this is a stack, exhaust stack. So we can take a look at that in the 3D view. So here we have the stack and the source. So the next object that I'd like to discuss is the directivity of this point source at the top. Now, the program will identify that this point source is above a stack or a cylindrical object. That means it will not consider the directivity or the shielding effect or combine the shielding effect with the directivity. So the directivity, if you assign the directivity for that point source with a ISO 96 directivity, then it will not combine that with the shielding effect of the stack. Still, it is recommended to put in the point source above the stack, so in case you are losing other standards, that it doesn't combine the directivity with the shielding effect. So here we have the spectrum of the stack. Under values, we can see there is the directivity. This is a three-dimensional directivity. So let me open that up here. In the directivity library, we have this defined as ISO 9613-2 directivity. We go to the settings, and here under the settings we have the calculation based of ISO 9613-2 2024. And when we select that, the program will allow us to enter the radius or the diameter of the stack, the temperature of at the chimney mouth, and then also the speed of sound. In this case, this is for air. If you had any other flue ingredients or light nitrogen or other flue components that have a different speed of sound, then you would enter the speed of sound of whatever flue gas that you have here. So based on these parameters, the program will calculate the directivity. In this case, it's a rotational symmetric, so it basically defines for 0 degree one slice, and then the program will basically rotate it at 380 degrees around the stack for the different frequencies. So here we have the different frequencies here at the top, and then of course the higher you go in frequencies, the more directional the directivity. So here this is at 63 Hertz. We can go to 125, 1 kilohertz, and so on. All right. Like previous versions, we can turn on the grid, we can turn on the circles, and we can also rotate and visualize that directivity. All right. So let me accept, and it's back in here. We can go back to the source, the directivity of the stack, and then here maybe just I want to note that the directivity, there's a few changes. So we here have now horizontal rotation and a vertical rotation. Vertical rotation is for a stack, of course, could be typically 90 degrees going upwards. but if you had like a oil platform or if you had like a stack that may be sticking out the side of a building, then in that case you may want to be able to rotate. We would stick it out with a 0 degree, and then again we would rotate that on the surface of the building. So if we had a building wall like this, then you would rotate that accordingly. In this case, again, we set it up to 0 and 90. So the stack is directivity is pointing upwards. All right. A few additional things in terms of point source and line sources and area sources. With the new version under the general, there is now a checkmark activate source for calculation. So this could be if you have a source that you want to show, but it's actually not creating any noise for a specific run. So you can activate that, and still it would show in the display. So with that, you can turn on and turn off those objects. Same for industrial building. So here we have some industrial building. So here, when I open up this building here, then also there is a activation for the outdoor sources for calculation. All right. Same thing for line sources and for area sources. So let me switch over to another situation. So here we have a road noise model. There's a few changes in terms of the road input, in terms of the assignment. So here we have now, in terms of the width, road width, it's now on the main general page. Then of course the emission calculation, the bridge, and any type of nodes that you have. So here this is kind of one of the changes that we have here. In terms of updating, resetting road properties, there is a new option here under the tool section, others, reset road properties. Also works for railway properties. With that, all inputs, all the references in traffic information will be reset to 0. So if you load a certain scenario and you want to basically start from scratch and then reset and reassign all the traffic, you can do that reset right here under the tool section. Now in terms of exporting, under the fundamentals I mentioned earlier, there's now a TNM 2.5 and 3.1 export in the 64-bit version. That was not the case in the previous version 9. So here we have both incorporated. For TNM 2.5 to work for the import and export, you still need to have TNM installed on your computer and make sure that there is a path set to where TNM 2.5 is located. For TNM 3.1 and 3.2 interface, we are using the TXF format that TNM has, and it's a extended XML format, and all the data gets transferred through that XML format. Before you, again, just to reiterate, before you export from SoundPLAN, make sure that you go into Tools, select your project, and prepare your project for the TNM calculation or for the TNM export. So here's prepare situation for TNM calculation. So that will make sure that there is no lines that are crossing each other, like roads over roads, or elevation lines over roads, or elevation line over barriers. So all of that gets cleaned up and saved in this project, and then you can go back and the fundamentals and export to TNM 3.1 or TNM 2.5. So let me just do one of these export, TNM 3.1, and I'll export that and I'll call it TNM export 10/22/2024, and I'll save this. There's a few notes here at the bottom. TNM 3.2 and 3.1 does not allow for roads to be non-symmetric, so the road width has to be to the right and left the same number. In SoundPLAN you can change that, so if you have like a passing lane, or if you wider shoulder, you can have a bigger width to the right than to the left. So this is kind of what these error messages here on the bottom left are all about. So let me quickly show the import into TNM. So I'll open up TNM, and I'll File, I'll go Open, and I'll load this TNM project. Takes a while, and then it locates it in the right city with the right background, and it has all the objects where they should be in terms of the buildings, the roads, and additional ground definitions, etc. So let me close this again, and I want to continue with a few additional things in terms of the import. So here again we did the import and export TNM 2.5. There's a KML export that allows us to export all the input data to Google Earth. The QSI, if you want to interface to any other software for noise modeling. QSI is the quality standard interface. And then of course the shapefile and DXF import. Now in the file import, a few changes that are notable. The DXF import is now a little bit more elaborate in terms of the preview. So if I can open up a DXF file, the program will now show me all layers, and then as I select just specific layers, and I'll just go down here with my arrow just from one layer to the next, you can see each individual layer is displayed by itself. And if you have multiple layers selected, then it basically adds these layers. So here I have a housing area, I have the commercial buildings, residential homes. So all of these homes and buildings are basically now highlighted. And if I decide to load and import that, then it would import the highlighted layers in one go. Same thing if I would, for example, select the roads and the railroads, so it would allow it to import both of these layers at the same time. So that's a major change or improvement here on the DXF front. Then we have other imports like the GeoPackage. This is an open and non-proprietary platform, and I believe that over time more and more geographic information will be available in this GeoPackage. So that will include like buildings, building heights, roof types, and other sets of convention. And the whole thing is based on a SQLite database. So there's definitely more availability of electronic data in this GeoPackage format. There's of course now also an Excel file format import and a Sketchup file import. For the most part, Sketchup is likely to be used for the indoor modeling, where we have maybe more complex interior spaces that are defined in a SketchUp model by the architect. I only can recommend not to go overboard. For interior modeling, try to simplify the interior room geometry. Overloading the indoor model with very extremely detailed SketchUp model will result in extremely long calculation times. All right, so let me continue here with a few additional changes here. So I'll close the Geo-Database, and I will open up the graphics where I see a couple additional changes here. So I open up this project, and first one I want to show is a sheet that's called road noise model. And here you may already see it here in the top right corner. There is a scale, and this scale has the option or has additional information beside the color, the scale range 65 to 70. It also has a surface area in hectare. There's also in kilometers, square kilometers or meters, and a percentage. So these are parameters that can be activated in the settings or the scale layout. And here we have them all at the bottom of the scale layout. So we can select the size and the percentage. And for the size, we have option to use meter square, hectare, or square kilometers. The percentage, there's no change there. And then of course there's decimal places you can add. In this case, the hectare, it would probably make sense to do at least 1 decimal point. For percentage, yeah, you round it up to the full percent. All right. I think this is a great additional feature, especially if you have like residential community or areas and you want to compare the changes in additional noise. How does it change in terms of more noise being more noise exposure to higher noise levels, or changes to lower noise levels, and then also put it in percentage. Now the percentage here of course is relative to the total calculation area, and the same if you add these percentages together, right now they will not add up to 100%, and partly because there's quite a bit under 40 decibels. So if I add the lower interval, you can see there's 28% is below 40 decibels. All right. So you can use this, of course, for the overall noise impact, but you can also use that for the difference map. So let me load in that difference map. So this is a difference map of a barrier along the road. That's right here. And I loaded a difference, a contour map without the barrier minus the contour map with the barrier. So here we see these scale of 0 to negative or over negative 12 dB, and then also some increases. There is really no increased area, but a lot of area there is no change, plus minus 1 dB. And then of course these areas where we have improvement. So here again we can show the size. So in this case, plus minus 1 dB is 118 hectare. That's for the entire calculation area. So 85% of the calculation area has experienced no significant change due to the barrier. And then the rest is kind of, you can see 5%, 1 to 2 dB reduction, 3.8%, 2 to 4, and so on and so on. Over 10 dB reduction is less than 1%. All right, so this gives you again additional information for your report to also put it in perspective. How much reduction are we getting here? And then of course you also have the surface area that you can present. Some other changes in the graphics are not like huge, but noteworthy. Here, when we assign text to source names or receptors, we can of course load those in the file selection manager. As we load the situation, we can add, as part of the cartography, we can add the name in the loading process. Or if you have other parameters that you want to have for receivers, they could use the number. For sources, also a number. For traffic sources, you could take in the name of the road, the section name, and so forth. All right. So you are loading this into the sheet, and then here we can see that. Let me zoom in here. the property text. So here we can move that around, and you can see there's this line here that we have from the text to the object, and that gives us basically a reference. Okay, this is the generator 1, that's this point source. Here's generator 2, that is this point source, right? Generator 3, that is this source, or the crusher. All right. In terms of the map object types, there is a new parameter here for the property as text, and down here we can see in terms of the reference line to the text, we can select to show the line, and then we can also pick the color for the line. All right. Last parameter or change I want to show is a new in development in terms of the Façade Noise Map. With this version 9.1, we actually have contour colors on the facades. So SoundPLAN will create the contour lines on the facades, and we can set that up in the map object types. So here, show facade in scale colors, and then here we have use or as isophones. So you can go back to the original, which basically just shows the squares, or you can select that it also shows the isophones. All right. So when I open that up, you can see here this is a Tri-City project, construction project, and you can kind of see for the different facades how the noise, of course, depending on the shape of the building and the reflections, where the noise is coming from, and how it's propagating on the facade, can be, of course, very valuable also for any kind of residential developments. Now, the facade calculation also has a new feature where you can also tell the program that it calculates the noise levels on top of the roof. And in that case, when the isophones are plotted, it would also have a contour map on top of the roof. This, of course, works primarily only on flat roofs. That almost ends my video here. I just remembered one last thing that I wanted to cover, and that is in the industrial building we have a new roof option for buildings. So we open up these. There's an industrial building here, and in the general properties we can set up different roof layouts: flat roof, saddle roof, shed roof, and now also a barrel roof. We define the direction of the roof shape, and in this case I'll set it up to go up to about 4 meters up in height. Sections, yeah, in this case 6 is fine. I'll generate the roof, and then here we can see how this roof is set up now. Right. Okay. Which also means in the editor we now see 6 roof segments, which basically also allows us to define the indoor to outdoor calculation for the sources and so forth for, let's say, all the roof elements. We do that here. We can enable them as sources, and then of course calculate from inside to outside and define them as sources. That ends my overview of the highlights for version 9.1. I hope that was helpful, and if you have any questions, please leave a note in the question section or in the notes section in YouTube, or if you liked it, please give it a like. All right, thank you, and Bye for now.